Hello Algebra 1 students, we're going to solve some multi-step equations using the properties of equality here. In a previous video we talked about using either properties of equality or inverse operations. I tend to prefer properties of equality. If it's not working for you, request some one-on-one time with me, whether it's during intervention or during class, when we can work together just for a few minutes to talk about what it looks like when you do the same problems with the other method. And if you think that's for you, then communicate with me. I can do that. It's just that the bulk of you will probably benefit most from using the properties of equality. So without further ado, let's get started. Okay, so the goal, no matter what when you're solving an equation, the goal that you have here is to isolate that variable. You want to get that variable by itself. In this case, that's x. And with the properties of equality, you undo what was done to the variable. So in the first example, I like to talk about the journey that little x here took. So what did x do? Well, in x's journey, it started with getting multiplied by 5, and then that result had 2 subtracted from it, and you got 18. So if we're thinking undo what was done to the x, then we need to undo the minus 2 first by adding 2 to each side of the equation, leaving us 5x is equal to 20. And I like to set it up like so. You may have seen this from previous teachers. You may have seen something similar from me last year, trying something a little different, drawing that line all the way down the middle. I find that it tends to help most kids to get started immediately, keeps it organized. Now I've got a multiplication equation, 5 times x equals 20. I probably already recognize that x is equal to 4, but I should still show it to get into that habit of dividing by that coefficient. We get x equals 4. Let's go back and check it. I'll use purple and orange in light of the fact that it's almost October and Halloween is totally coming. And we check our solution by going back to the original equation. And this is the best advice that you can get as an algebra student starting now. Go back to that original equation all the way right up here and put in your value that you got for x and check it. If you do indeed get that the two sides are equal, you know you checked it and you know you probably got the correct answer. So you're using that order of operations kind of in reverse. So let's think about that before we start on this page here. Using that order of operations kind of in reverse. So I'm actually going to write the PEMDAS upward. Good old PEMDAS. So we're doing the subtraction or undoing the subtraction or addition step first. We're undoing the multiplication or division step second. And then that's kind of it. We don't really actually even use these. It's just sort of half the order of operations in reverse. Or maybe, I guess that's more like 2/3, isn't it? Let's try this problem over here. All the way to the left. I'll draw the line down my equal sign. All right, so I want to undo the addition or subtraction first. That means I want to undo the the minus 17 with a plus 17. All right, so 40 and 10, that's 50. 7 and 7 is 14, so 50 and 40, 64. Well, that's convenient because over here I have a negative 8x. And again, I may see what the solution is, but this is a really good one to make sure you just take your time and write out the rest of the math, because it's really easy to make a quick sign mistake right here and accidentally get a positive when the answer here should indeed be a negative. Let's double check. Negative 8 times negative 8 minus 17, what is that? That's 64. Minus 17. 64 minus 10 is 54. 54 minus 7 would be 47. And I did check it, and I do have the correct answer. Okay, next one. Undo the addition or subtraction. Now this one probably should have had addition in it so that you could see the opposite, but it didn't. It has subtraction again, so we'll undo the subtraction. Now we have r over negative 2 is equal to 17. So this is r over or r divided by negative 2. And again, you need to be in the habit of writing out this work. Okay, that's where we're at right now. It is something we need. We do not need to be skipping steps at the moment. And I ended up with an answer of negative 34, which I will go back and check. So now I plug it in for my r, negative 34 over negative 2 minus 12. So that's 17 minus 12, and that is indeed 5. And that is the correct answer. So we use our order of operations in reverse. Now, this is a good strategy most of the time. Now we have to look at some good old exceptions to those rules because math has tons of exceptions. Let's take a look at a couple. Okay, fractions. We can eliminate fractions by multiplying first. We want to make the fractions go away. Let's look at this one on the right. I mean the left. The left. Yeah, I write with my right, so that's the left. Getting a little punchy. It's a bit late. 2y minus 9, all the quantity all over 4 is equal to 11. Well, we can't add 9 here first. We can't because that's not a 9. It's a 9/4. And this is not really a 2y. It's a 2/4 y. And that's what I want you to think about here with this order of operations is, you know, this fraction bar is like a grouping symbol. So if you think about what happened to y, first it was multiplied by 2, then 9 was subtracted, and then that result was divided by 4. So the divided by 4 is the first thing we have to reverse. And we're going to do that by multiplying both sides by 4, and that's going to cancel out the 4's on the left-hand side. And that is why we use multiplication to get rid of fractions. From here, it's the same as before. Add 9 to each side. And that means we now have 2y equals, remember when you add 9 you can do plus 10 minus 1. 44 plus 10 is 54, minus 1 is 53. Uh-oh, it does not come out evenly. Don't panic, it'll still work. Y is equal to 53 halves. 53 halves is, let's see, half of 50 would be 25. Half of 3 would be 1.5, so 26.5 or 26 and a half. Sounds about right. Let's check it. Now, in algebra, you have the luxury, my friends, of leaving your answer as an improper fraction. And look, it's going to actually be easier to check this with an improper fraction for an answer than it is with a mixed number. Because when I plug in 53 over 2, and I multiply it by 2, the 2's cancel. So I get 53 minus 9 all over 4. 53 minus 9 would be 53 minus 10 would be 43 plus 1 would be 44 over 4, and that does indeed equal 11. So I know I had the right answer to begin with. So that big fraction like that, remember, think about what happened to y, and the divide by 4 is the last thing that happened, so it's the first thing that has to unhappen. Now this is a little different on this side. When we talk about eliminating fractions, in this problem, you're going to look to multiply by the least common denominator of all the fractions that are there. Now in this particular example, the fractions have denominators of 3, 8, and 2. Our least common denominator there is 8. And the quickest way to find least common denominator is to take your biggest number that's here as a denominator and look at the other numbers. Is 2 a factor of 8? Does 2 go into 8? Yes, it does. Is 4 a factor of 8? 4 go into 8? Yes, it does. That means 8 is your least common denominator, the smallest number that goes in, that has all the numbers going into it. And you're going to multiply by that least common denominator. And this is where your basic fraction knowledge is coming in handy. And this is where I need you thinking in this manner. Okay, look. 8 times 3/4 is 3/4 of 8. 1/4 of 8 is 2. 3 2's would be 6. So 3/4 of 8 would be 6, and 3/4 of 8, and then times c is going to be 6c. Minus 7/8 times 8 is 7/8 of 8. Well, that's easy. That's 7. The denominators would cancel. And then finally 1/2 of 8. That's 4. And there you go. So now from here, we just have to finish that off, except it's a -4. Ah, did you think you got me? You probably thought you got me on that one, didn't you? You didn't. Okay, so anyway, right now I have, yeah, half of that would be -4. Okay, so now add 7. Add 7. Giving me 6c is equal to 3. Divide by 6, divide by 6. And we end up with a half, 1/2. And we go back to check it. Okay, so 3/4 times a half. Ooh, some lovely fraction operations here. So 3/4 times a half will be 3/8, because it's numerator times numerator, denominator times denominator. 3 minus 7 would be -4, so -4/8, which indeed is equal to, when I can find the space, -1/2, which is what it's supposed to be. and the solution to my equation was positive 1/2. Okay, let's continue. Okay, other exceptions to the rule. In this case, let's look at this problem. We need to use the distributive property first to get rid of these parentheses. But I also wanted to point out another way we could actually do this problem, and we'll get to that in just a second. But let's use the distributive property briefly here. So we call it the double rainbow property sometimes. So negative 18 equals negative 3 times x, so negative 3x, and negative 3 times a minus 11, which is plus 33. We're going to solve that by subtracting 33 from each side. Be careful. Don't get caught up in the fact that that you're thinking, well, I have to get rid of whatever's on the left-hand side. Now, the variable's on the right-hand side. So we are going to have to subtract 33 here and not adding 18, because then you'll have a 0 on one side. Your point is to get the variable alone, not to get the entire side alone. Let's see, 18 and 33. Same sign, add and keep, so it's two negatives. 10 and 30 is 40. 8 and 3 is 11, so 51. And conveniently, that's a times table. And if you're not familiar with it, that's okay. Add these digits. 5 and 1 is 6. When you divide 51 divided by 3, you get 17. We'll go back and check it, but we're going to do that in a minute. First, I'm going to show you an alternate method. I'm going to even change colors for my alternate method here. Take a look at this. So if I take this same equation, and I notice that, this is multiplication right here. I could divide on both sides by that negative 3. And it would cancel out there, and I wouldn't even have to distribute. And look how teeny tiny the numbers end up. Now it's just add 11 to each side. And I get my same answer of 17 is equal to x, but I don't have to worry about knowing my 17 times tables. So when this coefficient, since it's just multiplying this difference, when this coefficient goes into that constant, why not divide it off to begin with? Regardless, let's go back to the beginning. Is negative 18 equal to negative 3 times the quantity 17 minus 11? Well, 17 minus 11 is 6, and negative 3 times 6 is indeed equal to negative 18. So we got that right. All right, I think this is our last slide coming up. Combine like terms wherever necessary. So this is another exception to our rule of undo using addition or subtraction first. In this case, we don't want to start adding or subtracting. We have to consolidate the variable before we can isolate the variable. So consolidate the variable first by combining like terms. Then from there, solve away. So I'm adding 6 to each side. 7n is equal to 21. I'm dividing it off. N is equal to 3. And we're going to plug it in the original equation. Now use the original equation. Don't use your simplified one. Because what if you made a mistake simplifying it? Oops, that's messy. Fix it. Fix it. Okay, so this is 9 minus 6 plus 12. 9 minus 6 is 3, plus 12 is 15. I think we did it. So, if these are not challenging enough for you, never fear. We will move forward rather quickly in class as well. If these are challenging for you, then get practicing on that IXL or come see me. You know my door is open Tuesday and Wednesday mornings. Just email me for a pass. All right, go ahead and keep on solving equations. I'll see you guys in class.